Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning. Today I want to talk about ecosystem resilience and practical conservation strategies that enhance resilience in the face of human-caused disturbances. Resilience is the capacity of an ecosystem to absorb disturbance and reorganize while undergoing change, so as to still retain essentially the same function and structure. We will look at three connected ideas. First, we will define resilience and some related technical terms. Second, we will examine specific case studies where management improved resilience. Third, we will discuss adaptive strategies that policymakers can use to prioritize actions. A few technical terms are important. Biodiversity refers to the variety of life at genetic, species, and ecosystem levels. Ecosystem services are the benefits people obtain from ecosystems, like clean water, food, and protection from storms. Net primary productivity is the rate at which plants convert sunlight into biomass that supports higher trophic levels. Two mechanisms contribute to resilience. One is redundancy. When multiple species perform similar functional roles, the system is less likely to collapse if one species declines. The other mechanism is feedback regulation. Negative feedbacks can stabilize populations and maintain system function after a shock. Let me illustrate with a case study. In the Philippines and elsewhere, mangrove restoration on degraded coastlines has increased juvenile fish survival and boosted local fisheries. Restored mangroves provide nursery habitat that increases fish recruitment, which supports both biodiversity and livelihoods. Another classic example is the reintroduction of wolves to Yellowstone National Park in the mid-1990s. When wolves returned, they reduced elk numbers and changed elk behavior. That release allowed willow and aspen to recover along stream banks, which in turn stabilized banks and improved habitat for birds and beavers. When we reintroduce a keystone predator, the whole food web can shift in a process called a trophic cascade. That Yellowstone example highlights a broader point. Some species exert effects that are disproportionate to their abundance. We call these keystone species. Protecting or restoring them can yield large benefits across an ecosystem. Climate change complicates resilience because it alters baseline conditions. For example, coral reefs are experiencing mass bleaching events more frequently as ocean temperatures rise. Even well-designed marine protected areas cannot guarantee reef survival if thermal stress continues to increase. Conservation practitioners therefore combine local actions with broader policy. Locally, we can reduce pollution, restore habitat like seagrass and mangroves, and create corridors that allow species to shift range. Broadly, we need greenhouse gas mitigation and policies that reduce land use pressure. Adaptive management is a practical approach. It treats actions as experiments. Managers monitor outcomes, learn from successes and failures, and adjust strategies accordingly. This approach is essential when uncertainty is high and conditions are changing. A useful decision tool is prioritization based on ecosystem services and vulnerability. For instance, protecting headwater forests yields clean water downstream and maintains water regulation services. Investing in those forests may provide higher societal returns than protecting less critical areas. Finally, social dimensions matter. Community engagement, local knowledge and equitable benefit sharing increase the chances that conservation interventions will be sustained. Without social support, many well-designed projects fail after initial funding ends. To summarize, enhancing resilience requires understanding functional roles like redundancy in keystone species, implementing targeted restoration and protection, and using adaptive management to respond to uncertainty. Combining local restoration with global climate action gives the best chance of preserving ecosystem services for future generations.
Listen again to part of the lecture, then answer the question.
When we reintroduce a keystone predator, the whole food web can shift in a process called a trophic cascade.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.